Hello, and thanks for using TickBoom. For this question, we're looking at question number 1, and we've been given two functions, fx and gx, that we want to chart on the same system of axes and label all the intercepts. We want to use our graph to determine where fx is greater than or equal to 0. And then we want to calculate where fx is equal to gx and solve the inequality fx less than gx. And the key for this is to do all of that using our chart. So whilst you could probably work this out using algebra, you probably just need to know about the quadratic formula. But assuming you did know about that, you could do all this algebraically. But for this question, we're going to do it using charts. So step 1 will be to draw up our chart. So I'll just create an axis here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'll label these X and Y, 0 for the origin. For our horizontal axis, I'll go up in increments of 1. For our vertical axis, because I can see that we're going to be dealing with some bigger numbers based on the function we've got, I'm going to go up in units of 4. Now that's okay to do. It might affect the shape of the curve in terms of how squashed or stretched it is. But ultimately, it's perfectly valid to pick different increments for different axes. As long as you have the same increment on the same axis, that's what's most important. Alright, so our first function is fx is equal to negative x squared plus 9. To plot this, the process is fairly simple. It's quite straightforward. You pick values for x, insert them into the function, work out fx, and plot that on y. So a good place to start is often x is equal to 0. For us, that would be 0 squared is 0, minus 0 is still 0, so we get 9. And because we're told to label all our intercepts, and this is the intercept on the y-axis, I'll label that 9. If we pick now x equals 1, 1 squared is 1, minus 1 plus 9 is 8. And if I do that for negative 1, I'll get negative 1 squared is 1, minus 1 plus 9 is also 8. So we see that we're going to get symmetrical results, and that comes from the fact we're squaring things. And when you square a positive or a negative number, you get the same result. If I go x is 2, 2 squared is 4, minus 4 plus 9 is 5. And I'll also get that with x is negative 2. And if I go x is 3, 3 squared is 9, minus 9 plus 9 is 0. So we see that this function intercepts the x-axis at 3 and negative 3. They're already labelled, so I don't need to add any new label. I've got enough points here now to connect the dots. We can see that we're dealing with the parabola here. And I'll just label that y is equal to fx. Okay, for the second function, I might pick a different colour. So we had gx is equal to 6 minus 2x, okay. Same process, when x is 0, 6 minus 0 is 6. And I'll label that. When x is 1, 6 minus 2 times 1 is 6 minus 2 or 4. When x is 2, we get 6 minus 2 times 2, or 6 minus 4 is 2. When x is 3, 6 minus 2 times 3 is 6 minus 6, or 0. So there's one intercept. If I take the negative values for x, 6 minus 2 times negative 1 becomes 6 plus 2, or 8. So another intercept there. 6 minus 2 times negative 2 becomes 6 plus 4, or 10. And then 6 minus 2 times negative 3 becomes 6 plus 6, or 12. And again, that's probably enough points there to connect the dots. And we see that this chart is a straight line. And I'll call that y is equal to gx. So that's part 1 of the question. The next part asks us to work out for which values of fx is greater than or equal to 0. Now, that essentially means when is this blue chart, which is fx, above the x-axis, which is this area here. And we can see that that is true when x is between negative 3 and 3. So we can just say that when x is greater than or equal to negative 3, or less than or equal to positive 3. So again, I mentioned before you could work that out algebraically, but it's quite a simple thing to do once you've created the chart. The next part of the question is, when is fx equal to gx? And we can see that happened at 2 points. It happened when x was equal to negative 1, and it also happened when x was equal to 3. So again, once we've got our chart, a fairly simple thing to do. You could have algebraically made these two functions equal, rearranged, you would have ended up with a quadratic. You could have used the quadratic formula to solve. But the point of this question is to show you that charting is an alternative way to work out something like that. The last one was, when is fx less than gx? And we can see that happens 2 times. That happens over here, where the blue line is below the red line, and it happens over here too. So we can again say that happens when x is less than negative 1, and it happens when x is greater than 3. And we don't include the equal signs here because we're only asking when f is less than gx, not when it's equal to. So we had the equal to up here. Now we're only asking when it's less than. So it's when right after negative 1, but not including negative 1. And the same with 3. And that's in contrast to up here where, because we had greater than or equal to 0, we included our equal to's in this range. And that's really all there is to this question. So hopefully you found that helpful. And tick boom.